Hello students, we are discussing integration by parts, and in this module we will take an interesting question and some CET shortcut. So let's take the question. It says evaluate the integral x square e raised to 3x dx. So let's go to evaluate this particular integral. Now the function x square belongs to the algebraic category, whereas the function e raised to 3x belongs to the exponential category. So we have identified which function is to be taken as u and which function is to be taken as v. So let's apply the u into v rule. So that will give us x square integral e raised to 3x dx minus d by dx of x square integral of e raised to 3x dx the whole dx. Is that okay, my dear students? So what we write in the next step is x square as it is. Integral of e raised to 3x will be e raised to 3x by 3 because coefficient of x is 3. Likewise, minus of integral of 2x into e raised to 3x by 3, correct? Now, in the next step, the first part remains as it is. Minus 2 by 3, which is a constant, will be outside the integral, and what is left is x e raised to 3x dx. Now again we have product of two functions, so we'll apply u into v rule again, that is we are applying the second time. So let's consider u as x and e raised to 3x as v, correct? Now my dear students, apply u into v for the integral. So what we'll get is minus 2 by 3 as it is, x integral e raised to 3x dx minus integral d by dx of x integral of e raised to 3x dx the whole dx. Is that okay? So 1 by 3 into x square e raised to 3x minus 2 by 3 into bracket x e raised to 3x by 3 minus of 1 into e raised to 3x by 3. Correct? Now my dear students, what we will do now is we'll open the brackets for the last half of the integral. So what we'll get is 1 by 3 x square e raised to 3x minus of 2 by 9 x e raised to 3x, and because it is minus of minus, what we'll get is plus of 2 by 9 integral e raised to 3x dx. Only one small integral left to be evaluated, so let's evaluate that. What we will get is plus of 2 by 9 into e raised to 3x by 3, and since integration is over, a plus. Now let's rearrange this answer. Can I say every term has a e raised to 3x and a by 3 also? Correct? So let's take a e raised to 3x by 3 common, and what is left inside the bracket will be x square. Then we have a minus of 2x by 3 and a plus of 2 by 9 plus c. This is our final answer. Now what was unique in this sum is we had applied u into v twice. On the same lines you have to try these particular questions. Okay, now let's see some generalized formulae based on this particular example. So this is the answer we got for this particular example. Now my dear students, if I assume x square to be a function of x, which is represented by f of x, and if I see the right hand side, I can say the right hand side very much has the same function. So we have f of x. Then the next term following it is nothing but derivative of x square. So can I say it is f dash of x? And the last term which I have is nothing but derivative of 2x, and therefore I can say it is f double dash of x. So what I have inside the bracket is f of x, f dash of x, f double dash of x. After that, if I take derivative, it becomes 0. Therefore you don't see it. Likewise, if I consider the coefficient of x to be a, what I observe is the coefficient of x, if I take it as a, the answer has a in the denominator for the first term, then a square, and then a cube. Correct? Also, the terms have an alternate plus and minus sign. Now, let's go to generalize this. Now, if I have something like x cube e raised to ax, then my answer should have e raised to ax outside. X cube is my f of x, so first term will be x cube, then its derivative, which is 3x square, then its derivative, which is 6x, and then a 6. Also in the denominator, what I'll get is a for the first term, a square for the second, a cube for the third, and a raised to 4 for the fourth. And now alternate plus minus, the first term is positive, second is negative, third is positive, fourth is negative, and the last we'll write is plus c. So likewise students, if I have to evaluate integral x cube e raised to x dx, what I'll get is e raised to x into bracket x cube 3x square 6x 6, and the signs will be first term positive, second negative, third positive, fourth negative, and then a plus c. Likewise, if I have x raised to 5 e raised to x dx, e raised to x will be outside. The first term will be x raised to 5, then 5x raised to 4, then 20x cube, 60x square, 60x, 120x and 120. Obviously, the first term will be positive, second is negative, third is positive, fourth is negative, fifth is positive, sixth is negative and a plus c. Is that okay, my dear students? Now let's generalize this. So if I have a function of x which is a polynomial in x of the nth degree, then the integral e raised to x f of x dx is given by e raised to x into bracket f of x plus f dash minus of f dash of x plus of f double dash of x and so on, and the last term is minus 1 raised to n f of x. This is how we will evaluate something of the type e raised to x into f of x, where f of x is a polynomial of nth degree. That's all we have in this module. Thank you very much.